The photograph hit me before the theory did. An image from 1911. For men. A tripod camera. Standing at the edge of something impossible. Not a peak, not a ridge, a flat surface, perfectly flat, like it had been. Cut. I remember staring at it longer than I should have, because something felt wrong. Not obviously wrong, but quietly wrong, like a sentence with one word out of place. You can read it, but it doesn't sit right. And once you see it, you cannot unsee it. The official story goes like this: mountains are formed over millions of years. Tectonic plates collide. Land folds. Pressure builds. Volcanic activity pushes rock upward. Erosion shapes the rest. It's slow, gradual, natural. And to be fair, there's overwhelming evidence supporting this. The Himalayas are still rising today due to the collision between the Indian and Eurasian plates. Volcanic mountains like those in the Pacific. Ring of fire follow predictable geological patterns. Sedimentary layers, fossil records, mineral compositions, they all align with this explanation. Let me be fair to the official narrative. It works most of the time, but not everywhere, because scattered across the world are formations that don't behave like mountains, don't look like mountains, they don't erode like mountains, and more importantly, they don't form like mountains. Let's start with the numbers in Devil's Tower. The structure rises over 1,200 feet from its base. Its sides are nearly vertical. Its top is strangely flat. Geologists describe it as an igneous intrusion, magma put upward, cooled, and then surrounding rock eroded away. That's the explanation, but here's what matters. The vertical columns perfectly formed, almost symmetrical, as if something cooled all at once. The timeline isn't subtle. Now move to Giant's Causeway, around 40,000 basalt. Columns interlocking hexagonal like a honeycomb made of stone. Again, the official explanation points to volcanic activity. Rapid cooling of lava created these shapes. And again, that explanation works until you start comparing, because these formations, they repeat across continents, across climates, across geological timelines. Speaking of repetition, there's a pattern that keeps showing up. Flat tops, not rounded peaks, not jagged ridges. Flat. Which brings me to something else entirely. In Table Mountain, the summit stretches for miles, a massive plateau flat enough to look intentional. The official explanation attributes this to erosion. Wind. Water, time wearing down the mountain evenly. But erosion isn't precise. It doesn't create symmetry. It doesn't stop at a perfect horizontal line. That's not randomness, that's consistency. And consistency is where patterns begin. I found this while researching something else entirely. A Geological Survey report dated June 18, 1923, archived under the United States. Geological Survey buried in plain sight. It describes several flat-topped formations across North America. Uses terms like unusual truncation and abrupt termination of vertical growth. Those aren't casual words, they're careful, measured. Almost cautious, as if describing something without fully explaining it. The timing is almost theatrical, because around the same period, late 1800s to early 1900s, there's a surge in photographic documentation of these formations. Explorers, surveyors, early photographers, capturing images of landscapes that looked different, less eroded, more defined. Sharper than then. Something changes. Fewer photographs, less documentation, more standardized explanations. Which brings me to the gaps. Archival gaps. Entire collections labeled but inaccessible. Documents referenced, but missing. Photographs mentioned in logs but never published. Sitting in a filing cabinet somewhere, or perhaps not sitting anywhere at all. Maybe it's coincidence, maybe records get lost, maybe photographs degrade, maybe explanations evolve, maybe... But let's keep going. Because the pattern doesn't stop at shape. It extends to scale. Some of these formations are enormous. Miles across, thousands of feet tall, and yet they share the same characteristics. Flat tops, vertical sides, layered textures that resemble something organic. That's not geology speaking. That's observation. And observation leads to uncomfortable questions. What no one explains is this: why do these formations resemble stumps? Not metaphorically, visually. Circular tops, radial patterns, concentric rings in some cases, like growth rings. That's not proof, but it's not nothing either. Speaking of patterns, there's a related anomaly. Silicified wood, petrified forests found across the world. Trees turned to stone over millions of years. The official explanation is mineral replacement. Organic material replaced by silica. It's well documented. But here's what matters. Some of these petrified trees are massive, far larger than anything alive today, and that raises a question. If trees could grow larger in the past, how large? Maybe not 40 miles, that's where speculation begins, but larger than we understand. That's already documented. Which brings me to the uncomfortable part. Maybe These formations are exactly what we think they are. Mountains, formed naturally, explained scientifically, understood completely maybe, or maybe they're something else entirely. Maybe they're remnants of something larger, something older. Maybe I'm seeing patterns where none exists, but the repetition is difficult to ignore. Flat tops, vertical sides, global distribution, independent formations, sharing the same characteristics. That's not random. That's a signal. And signals demand interpretation. I don't have answers, only patterns. And the pattern doesn't stop where you expect it to. Because once you start mapping these formations globally, you notice something else. They don't just repeat in shape, they repeat in timing. The timeline isn't subtle. Late 1700s, early 1800s. A surge in exploration reports, detailed sketches, field journals, descriptions that feel, observational, not interpretive. Then suddenly, mid to late 1800s, the language changes. More certainty, more classification, less curiosity. That's not unusual on its own. Science evolves. Terminology improves. But here's what matters. The shift happens fast. Almost too fast. Which brings me to a document I wasn't even looking for, dated October 3rd, 1872. Filed within early survey records tied to what would later become Yellowstone. Mapping archives. Note, referencing shear-sided elevations with flattened crowns, not peaks. Not summits. Crowns. That's, single quotes, is not geological language, that's descriptive, almost biological, and it appears only briefly, then disappears from later reports. Maybe terminology standardized. Maybe earlier observers lacked precision. Maybe, but words matter, especially first impressions, because first impressions are often the least filtered. Speaking of Yellowstone, there's another formation worth noticing. Sheep-eater cliffs, basalt columns again, stacked, vertical, clean edge, repeating geometry. The official explanation points to lava flows, cooling slowly, cracking into polygonal columns as they contract. And yes, that process is real. It's been replicated in labs, observed in smaller formations. But scale changes. Perception. Because when something becomes massive, our assumptions scale with it. We stop questioning what we start accepting. That's not science, that's comfort. Which brings me to something that kept bothering me. Erosion, we're told. Erosion shapes mountains over millions of years. Wind, water, ice, time, and that's true. But erosion is chaotic, uneven, asymmetrical. It doesn't carve perfect horizontals across vast surfaces. It doesn't stop at the same level, and yet, across continents, we see similar truncation levels, not identical, but close enough to raise an eyebrow, which raises a question no one really asks. Why do so many of these formations appear cut, not worn down, not collapsed? Cut. That's not a conclusion. That's an observation. And observations are where patterns begin. I found this while researching something else entirely, a reference to early photographic plates held by the Library of Congress. Collections from expeditions between 1860 and 1900. Some labeled, some catalogued, some restricted. Descriptions mention unusual formations, unnaturally abrupt surfaces, and in one case a plateau resembling the cross-section of timber. That phrase again, timber, wood, biological language, applied to stone. Maybe it's a metaphor. Explorers trying to describe unfamiliar shapes. Using familiar terms, that happens. But it happens. Repeatedly. Which brings me to pattern reinforcement. Different observers, different locations, similar descriptions. That's not coordination. That's convergence. And convergence is difficult to dismiss. Let me be fair to the official narrative again. Geology explains a lot. Plate tectonics, volcanic activity. Sedimentation. These processes are measurable, predictable, testable. They work, but not perfectly, because there are edges to every model, cases that fit, almost, but not entirely. In those almost states, where investigation begins, maybe these formations are volcanic remnants, maybe they're erosional plateaus, maybe they're just rare geological coincidences, maybe, but here's what keeps me up at night. The scale of repetition. North America. Africa. Europe. Asia. Independent. Systems. Similar outcomes. Flat tops, vertical. Walls, layered interiors. That's not one anomaly, that's a category. And categories demand explanation. Speaking of categories, there's another parallel worth noticing. Quarries. Quarries, large-scale stone. Extraction sites. Flat-cut surfaces, vertical. Walls. Step-like layers. That's not nature, that's design. Now compare that visually to some of these formations. The resemblance isn't perfect, but it's close enough to be uncomfortable. That's not proof of anything, but it's not nothing either. Maybe it's coincidence, maybe. Our brains are wired to see patterns, to connect unrelated shapes. That's a valid explanation. But then you look at the consistency again, and the doubt returns. Maybe these formations are natural. Maybe they're not. Maybe we're interpreting them correctly. Maybe we're not. But here's the part that lingers. If something doesn't fully fit the model, do we adjust the model, or do we adjust the observation? History suggests as we often do the latter, because it's easier, cleaner, less disruptive, and disruption isn't comfortable, which brings me back to the photograph from men, a tripod camera standing at the edge of something impossible. They weren't theorizing. They weren't explaining. They were observing, capturing something as it was before it was categorized, before it was explained, before it was normalized. And that matters because normalization changes perception. What once looked strange becomes familiar. What once raised questions becomes accepted, and eventually invisible. Maybe that's what happened here. Maybe nothing was hidden, nothing erased, nothing concealed. Maybe we just stopped noticing, stopped questioning, stopped looking closely. Maybe there are patterns we were never meant to follow, questions we were never meant to ask, details hiding in plain sight, because once you start seeing them, truly seeing them, you can't go back. You look at a mountain and hesitate just for a second, and that second changes everything. I don't have answers, only patterns, and once you see them, you cannot unsee them, and maybe that hesitation is the point, because history isn't just what happened, it's what was recorded, what was preserved, what was repeated often enough to feel unquestionable, and sometimes the absence of a question is more revealing than any answer. The archive still exists, survey reports, field notes, photographic plates, sitting in controlled rooms, catalogued, indexed, buried in plain sight. Some are digitized, some are sealed until future dates, some referenced, but never fully published. That's not unusual. Institutions like the Smithsonian Institution and the British Geological Survey hold millions of documents. Not everything is accessible. Not everything is prioritized. That's the nature of archives. But it leaves gaps, and gaps invite interpretation. What no one explains is why certain descriptions fade out, why early observers used language that later disappears, why visual anomalies become normalized through terminology. That's not censorship, that's evolution. But evolution, it can also obscure. Maybe these formations are exactly what we've been told, products of immense pressure, time, heat, movement. Maybe every flat surface, every vertical wall, every repeating structure has a perfectly reasonable explanation, maybe, but patterns don't disappear just because we explain them. They persist, quietly, waiting, and sometimes they wait until someone looks just a little closer, not to prove anything, not to claim certainty, just to notice, because noticing is where it begins. The shift, the question, the moment something familiar becomes unfamiliar again. You look at a mountain, a place you've seen your entire life, and for a fraction of a second, it doesn't look the same. That's not proof. That's perspective, and perspective is powerful, maybe too powerful, because once enough people start seeing the same thing, questions multiplied in questions have consequences. So maybe the real story isn't about mountains, maybe it's about attention, what we're taught to see, what we're taught to ignore, and what happens when those two things no longer align. I don't have answers, only patterns, and the patterns suggest something simple. Not that the world is different, but that the way we look at it might be. And once that shift happens, even slightly, do you see landscapes anymore? Do you see possibilities in that? It's much harder to explain.